In this lesson, we are interested in finding graphs of reciprocal functions for the given quadratic functions. So the given function is quadratic. Here, given function is y is equal to x square, which obviously is a quadratic function with vertex at origin and changes in its values of y follow a pattern which is standard for parabola, pattern 1, 3, 5, 7, and so on. So with this vertex and changes in the values of y, we can draw the graph of this function. Vertex is at 0, 0, and following the pattern and changes in the values of y, we have 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, 1, 2, 3, 4, 5. And basically the same pattern is followed on the left side for negative values of x. So there will be a point here, then there will be a point here, and then there will be a point right here. And we can draw the function of the given graph. So here is the graph for the given values. And this is the equation y is equal to x square. Now we take a look on its corresponding reciprocal function. Corresponding reciprocal function is y is equal to 1 over x square. For this function, we are going to find out few objects. The first thing that we need to find is asymptotes. So asymptotes, and we know horizontal asymptote is like by comparing coefficient of highest power of x to 0, we can find the horizontal asymptote. Coefficient of highest power of x. Coefficient of highest power of x equal to 0. This means y is equal to 0. So this is the asymptote. Y is equal to 0 means x-axis itself. Therefore, here is our one asymptote, which is y is equal to 0. Now let's find out the vertical asymptote. For vertical asymptote, now we compare coefficient of highest power of y equal to 0. Coefficient of highest power of y equal to 0. This means x is equal to 0. So y-axis itself is vertical asymptote. So y-axis itself is vertical asymptote. And next thing we need to find is invariant points. So number 3, we want to find out invariant points. Invariant points. And for invariant points, we keep y is equal to 1 and y is equal to minus 1. For this, y is equal to 1 and y is equal to minus 1. So let's put y is equal to 1. This means 1 is equal to 1 over x square. And if so, this means x square is equal to 1, or values of x are plus minus 1. Therefore, the invariant points are 1, 1 and minus 1, 1 are invariant points. Invariant points. But if you take a look on the other hand, for y is equal to minus 1, we get minus 1 is equal to 1 over x square, means x square equal to minus 1, which tells us that there is no real value of x for which x square is equal to minus 1, which shows that there is no real number for which x square is equal to minus 1. So there is no invariant point against y is equal to minus 1. So let's plot these points on the grid. And now we have these points. This is one invariant point, and this is another invariant point. 1, 1, and here this is the point minus 1, 1. And let's also find out if there are any intercepts. So for x-intercept, for x-intercepts, put y is equal to 0. If so, this means 0 is equal to 1 over x square. This means there is no x-intercept. There is no finite x-intercept, because the only way y could be 0 if x approaches to infinity, and infinity is not a permissible value. Similarly, for y-intercept, for the same reason, there is no y-intercept. There is no y-intercept as well. So now we have the situation where we have the information regarding the intercepts, we have invariant points, we have asymptotes. Before we can figure out the path of the graph, let's find out the long run behavior and short run behavior of y. So long run behavior. Long run behavior. Long run behavior is when x approaches to infinity. like when x becomes very, very large, here you can see that y is equal to 1 over x square. So this means y approaches to 0. So for very large values of x, the graph of the curve gets closer and closer to x-axis so that y becomes almost equal to 0. And short-run behavior is short-term behavior is when x is very small. When x approaches to 0, we can see that y becomes very, very large. Y approaches to almost infinity. And for any value of x, there is no negative value of y. It means the graph of the function doesn't exist in the lower half of the plane. Also, notice that for any value of x, y is always greater than 0, means that the graph doesn't exist in the lower half of the plane, which tells that graph does not exist in lower half of plane. Now let's draw the graph of this on the grid, and we have invariant points. We know that y-axis is asymptote, so let's bring the graph from infinity and start it moving out because it has to pass through this point. And similarly, for the graph coming on the other side, this graph has to pass from the point this. And now the graph must travel all along negative x-axis as well as positive x-axis. So this is the graph. Because it doesn't exist in the lower half of the plane, so this is all y is equal to 1 over x square. This is the graph of the reciprocal function. You can try finding graphs of other reciprocal functions which are quadratic. For example, example 2, find graph of reciprocal function for y is equal to x square minus 4. So this will be an interesting situation. Here again we need to have a grid. So let's have a grid here and move this grid over this side a bit. And the graph of y is equal to x square minus 4 is a parabola with vertex at 0, 4, minus 4. So 0, 1, 2, 3, minus 4. So this is 0 minus 4, and there is another identification for the vertical asymptotes that intercepts. So the reciprocal function is y is equal to 1 over x square minus 4. But for the graph of y is equal to x square minus 4, the changes in values of y occur with the same pattern of 1, 3, 5, 7. So 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, 1, 2, 3, 4, 5 here. And similarly, these points are here and here, and 1, 2, 3, 4, 5. Let's draw the graph of parabola y is equal to x square minus 4 through these points. And this is the graph that we get for the given function y is equal to x square minus 4. And now we want to draw the graph of its reciprocal function y is equal to 1 over x square minus 4. So obviously we are going to find out its asymptotes. Vertical asymptotes are x square minus 4 is equal to 0, means x equal to plus minus 2. So here this line is the vertical asymptote. So let's just draw the line here as well as line on this side here. So these are two lines. For the asymptote, one is x equal to 2. This one is x equal to minus 2. Now we will find out horizontal asymptote. Horizontal asymptote. And for horizontal asymptote, we are going to compare coefficient of highest power of x to 0, which is y is equal to 0. So x-axis is horizontal asymptote. Horizontal asymptote. So once you have vertical asymptote as well as horizontal asymptote, which is y is equal to 0, now we need to find out the invariant points. Invariant points. For invariant points, substitute y is equal to 1. So put y equal to 1 and y is equal to minus 1. So let's put y is equal to 1. This will give us 1 is equal to 1 over x square minus 4, and this gives x square minus 4 is equal to 1. This means x square is equal to under root 5. Sorry, x square is equal to 5, or x equal to plus minus under root 5. So the two invariant points are under root 5 1 and minus under root 5 1. And let's see if there is any invariant point for negative values of 1. So this means minus 1 is equal to 1 over x square minus 4 means x square minus 4 is equal to minus 1, and again x square is equal to minus this is plus 4 minus 1 means x equal to plus minus under root 3. So the two other variant points are under root 3 minus 1 so under root 3 minus 1 and minus under root 3 minus 1 are other invariant points or other invariant points. We have found asymptotes, we have found invariant points. Let's see if there is any x-intercept or y-intercept. X-intercept, put y is equal to 0. This means 0 is equal to 1 over x square minus 4, which is absurd, which shows no x-intercept for finite values of x. For finite values of x. Similarly, y-intercept and for y-intercept we are going to put x equal to 0, put x equal to 0. This means y is equal to 1 over 0 square minus 4 means that y is equal to minus 1 by 4. And now let's draw the graph, and the graph is going to be like this, because here this is invariant point under root 5 1, and this is invariant point minus under root 5 1. It means the graph will come from this side because that's asymptote, and this also can be found by finding the long run and short term behavior of the graph, and then it will bend toward here and will go along this asymptote. So that is the graph on this side, and similarly we have a graph on this side which comes along and passes through this invariant point and goes along this asymptote. Now because we have also 0 minus 1 by 4 as a point on y-axis for intercepts, so it means the graph also passes through this point, and the possible path that could be made is this. And here this is the possible path of the graph. So this is graph of y is equal to, so y is equal to 1 over x squared minus 4. And in fact, when you do this, use one color of pencil for the given equation of the function and use another color for drawing graph of the reciprocal function.